Everybody, 2.4 chain rule. So as JM was talking about today, you use chain rule when you have composite functions. So for example, up to this point, we've just been deriving sort of functions like y is equal to x squared plus 1, or y is equal to sine of x. These are pretty straightforward and easy to solve, but they become harder if you make them x squared plus 1 to the power of 10. So you have two functions. You have the x squared plus 1, and that is inside the power of 10. So there's a composite function there. And you don't want to expand this one to the power of 10 because that's going to take forever and probably going to make a bunch of mistakes on the way. Now, sine of x, that becomes complicated if you either write sine of x all squared, which is written as sine squared x. So again, the sine is inside of the square. Or you write y is equal to sine of 5x squared. So what's inside of the sine, the 5x squared, is now inside of the sine function. So you have a function inside of a function. The key point when you're doing when to use chain rule is recognizing an inside and an outside function. So power of 10 would be the outside, and the inside obviously is the x squared plus 1 here. Again, same for the sine x all squared. The outside is a square, the inside is sine. For this one, the outside is the sine function, and the inside is the 5x squared. Okay, so these are composite functions, and you need to use chain rule when you see them. So, what is chain rule? I'm going to show you a couple different ways of looking at formulas. They're basically the same as what Jean-Marc said, but so chain rule says the derivative of a function is a composite function. So we have an outside function, which is f, and an inside function, which is g. Derivative of that is the derivative of the outside, so f prime of g of x times the inside derivative, which is g prime of x. So this is the outside derivative, and this is the inside derivative. And just for completeness, f is the outside function, and g is the inside. So you can see how they relate. You just take the derivative of the outside function, and you multiply it by the derivative of the inside function. Okay, now there's another way to look at chain rule. It's called the general power rule, and this seems to make a little more sense for students, but I don't want to speak for everybody. So general power rule, which says this: if y is equal to u to the power of n, then y prime is equal to n, drop the exponent down, u to the n minus 1. So that's our regular power rule. But now we multiply by the derivative of u. So u primed. Okay? Yeah, and this is the one that most kids seem to make a little better. So I'm going to go through a few examples here. So if we have, and the function u is a function of x. That's why we can take the derivative of it. So the easiest example is ones that you've seen before, some polynomial or binomial, such as 3x minus 2x squared, and I just put it to the power of, 4. Doesn't matter. We don't want to expand that because that's going to take forever. So what we do is we use chain rule or power rule. So the derivative is 4 falls down. This is where the general power rule makes a little more sense to students. 4 falls down. 3x minus 2x all squared. Take 1 away from the exponent, so it's the power of 3. This is because 4 is the outside, This is the outside derivative. And then we multiply by the inside derivative, which is, this is the inside function. The inside derivative is 3 minus 4x. And that's it. It's over. You're done. Walk away. We're going to get into ones, as you saw today, that the simplification becomes more important. But for right now, we'll just start with some straightforward ones. We have f of x is equal to 1 over x squared plus 1. So this is the stuff I was telling you yesterday. It looks like it would be a quotient rule. But now that we have chain rule, we can rewrite this as x squared plus 1 to the power of negative 1. So our derivative, f prime, negative 1 falls down. Take 1 away from there, so you get negative 2 times the inside derivative. The derivative of x squared plus 1 is just 2x. And you're done. We can clean it up because that's a negative exponent. I'll drop it to the bottom. So I get negative 2x over x squared plus 1 all squared. Okay. If you want practice just on sort of the basic ones like that, you're going to go to page 136, numbers 7 to 21 odd. You can take a break, stop the video, come back, because now I'm going to start looking at some more basic trig ones before we get into the really crazy stuff. All right, trig plus chain rule. So we'll start with a simple one. Y is equal to sine 2x. Okay. The outside function is sine. Okay. The inside is 2x. So y prime is going to be the derivative of the outside. What's the derivative of sine? It is cosine of 2x times the inside derivative. What's the derivative of 2x? It is 2. That looks gross, so we tend to write the 2 at the front. So we would just write 2 cos 2x. And that's it. Now, what if you have a more complicated function? Cos of x squared plus 2x. Well, it's the same thing. Start with the outside. The outside is cosine. So derivative of cosine is negative sine of whatever was in there. That stays with it. Then you multiply by the inside bit. So what's the derivative of x squared plus 2x? That is 2x plus 2. You can move the 2x to the front if you really wanted to. So you get negative 2x plus 2 sine of x squared plus 2x. I mean, you could expand that, but it's not going to really make your life any easier right now. Okay. Now, y is equal to tan squared of 3x. Remember, when the square is on the trig function, that means this, that the whole thing is being squared. And that's when you can really see the outside versus the inside function. So the outside function is the square. The inside function, there's two of them. This is like what I told you yesterday, a nested trig function. There's three functions here. There's the square, then there's the tan, and then there's the 3x. So y prime is going to be, drop the 2, you start on the outside. So I get 2 tan of 3x, take 1 away from the 2 is 1, times the next function in is tan. What's the derivative of tan? Well, we learned that yesterday. We proved it. Derivative of tan is secant squared. So I get secant squared of 3x. And then the next function in is the 3x. The derivative of 3x is 3. So I can multiply the 3 and the 2 together to get 6 tan 3x secant squared 3x. You can just leave it like that. We might simplify later on, but for right now, we're just going to leave it like that. We're just trying to get used to trig functions. All right, next one. Y is equal to cos of x squared. This indicates that the square is on the x. Okay, so it's like that. So the outside function is cosine. Derivative of cosine is negative sine of x squared times inside derivative. What's the derivative of x squared? It's 2x. So it's negative 2x sine of x squared. All right. What about this? Cos of 3 times x squared. So I know your intuition is to say, oh, it's going to be product rule because it's x squared times cos of 3. I could write it like this. But it's not product rule because cosine of 3 is a constant. So we just ignore it. You can pull constants inside and outside. So we go, okay, well, y prime, I can pull cos of 3 out. And this, do the derivative of x squared, which is 2x. So the answer is, well, you could write 2x cos of 3. I mean, the order is kind of irrelevant, but 2x cos 3. That's it. What about come on. Computer does not want to work today. 6. Yeah. So these are all versions of the same question, just getting you used to the notation. So now it's the 3x being squared, not the cosine. So to do the derivative, start on the outside. The outside function is cosine. So the derivative of cosine is negative sine of 3x all squared times the next function in is actually the squared, because the squared is just on the 3x, which is inside of the cosine. The derivative of, so just pretend that you had this. And I said, what's the derivative of that? You drop the 2 down, times the inside, which is 3x. Take 1 away, so the power of 1. I'm going to write the 1 just to illustrate a point here. And then there's still the function on the inside of that, which is 3x. What's the derivative of 3, or 3x? It is 3. So I can multiply this 3, and this 2. It gives me 18 times the negative on the outside. So I get negative 18x sine 3x all squared. All right. Now, final one. What if you have something like this? F of x is, we'll just do sine. Sine to the 4th power of 3x all squared. Okay, so what this actually means is this. Sine of 3x squared, all of it, is raised to the 4th power. So here we go, f primed. Start on the outside. That is the power of 4. The 4 falls down. You get sine of 3x all squared. But you got to remember, you take 1 away from the 4, so it's all cubed. Times, that's the outside derivative. Next function in is sine. What's the derivative of sine? It is cosine. So you get cos of 3x all squared. Once you've done that, you move to the next function, which is not 3x, like I pointed out. The next function is the squared there. So the 2 falls down, or it's the 3x squared. You can think of the whole thing all together. So we could just write 3x all squared, just like I did up here. The 2 falls down, times 3x, times the inside of that, which is 3. So 2, 3, 3. That's 18. Well, I can't do math. 4 times 2 is 8. 3 and 3 is 9. 8 and 2 is 72. I think that's right. 8 and 9, 72. We're just going to go with that. If I'm wrong, you'll correct me in class tomorrow. 72x times sine of 3x all squared to the power of 3. And there you go. So if you want practice with the trig ones, page 136, numbers 43 to 63, odd, 83, 89. I got a note to myself here. Not 51, 53, and 59. Okay. Please practice those, because the next video that I'm going to do in a sec here is combining product quotient rule. And you saw one of those at the end. They can get a little messy. So take a break, do some practice questions. Okay, we're back. So this is the question that Jam put on the board at the end. I'm going to show you how to solve it. I showed a couple people. I'm going to show you how to solve it in 2 different ways. Okay, so what we remember is, so this is 2 functions being divided. You can see there's a quotient here. So we're going to have to use quotient rule. So if you remember quotient rule, dx of u over v is u primed times v minus v primed times u over v squared. That's quotient rule. So what you want to do when you get a question like this is define something as u and v. So I'm going to call the top, that is u, and my bottom is v. So then I just go off to the side and I go, okay, if u is equal to tan of x cos of x, then u primed, just do it on its own. I'm going to use product rule here, which says the derivative of the first function, tan, we learned that yesterday, is secant squared times cos of x plus the derivative of cosine, which is negative sine, times the first function, which is tan of x. That's u prime. V is sine of x all squared. So v prime, we use chain rule. Drop the 2 down. I get 2. Sorry about this. Whoa. 2 sine of x. 2 falls down times the inside derivative, which is cos. So there's v prime. And when you do that, then you just plug everything into your quotient rule formula. So I go, okay. So I'm going to get f prime of x is equal to u primed, which is this big long thing, minus the sine of x, tan of x, times v, which we said was sine squared, minus v primed, which is 2 sine x cos x, times u, which is that, tan cos. Over v squared. V was sine squared, so if we square that, we get sine to the 4th x. Okay, now it's your grade 12 trig number 2 proving, in which case we get rid of all the sine, or the secants, the tans, the cotant, all of that goes away. Make everything sine and cos. So here we go. Secant is 1 over cos, so secant squared is 1 over cos squared. times cos of x minus sine of x times tan, which is sine squared over cos squared. Forgive me because I'm probably going to forget to put the x's in at some point. And times sine squared of x minus 2 sine x cos x. Tan is sine of x over cos of x times cos of x over sine to the fourth x. All right, now you start canceling. That cosine goes away with one of those. Why did I square the tans here? It should just be sine over cos, because tan is just tan. This cosine and this cosine go away. So now I end up with 1 over cos minus sine times sine is sine squared over cos times sine squared on the outside minus those cosines are gone, so I can multiply this times this, which gives me 2 sine squared cos of x. It's all over sine to the fourth of x. Okay. These already have a common denominator, so I end up with, I'm going to do it off this, I'll have to write it over here. 1 minus sine squared of x over cos of x times sine squared x minus 2 sine squared cos all over sine to the fourth. So you can see I'm starting to rush. Okay, 1 minus sine squared, if you remember your identities from math 12, sine squared plus cos squared is equal to 1. So if I move the sine squared over, I get cos squared is equal to 1 minus sine squared. So the top there becomes cos squared over cos times sine squared of x minus 2 sine x cos x, and that was a sine squared. Obviously, that cancels one of those. And sorry, I forgot, this is all over sine to the power 4. So now I'm left with cos of x sine squared of x minus 2 sine squared cos of x over sine to the fourth of x. These are like terms, so it's essentially 1 minus 2, which is negative 1. So I get negative cos x sine squared x over sine to the fourth x. That's gone. That becomes 2. I'm left with negative cos of x over sine squared of x. Now I'm just going to leave it there. You could simplify it further, but I'm just going to leave it like that. So that's a bit of a gong show. All right. You can see that took a lot. If I zoom in here, it's a lot of work. All right. But watch this. As with all trig, if you simplify first, or what I showed you yesterday, always try to simplify the function first. So if I write f of x is equal to, and I rewrite tan as sine x over cos of x times cos of x, and it's all over sine squared. That disappear. I have sine of x over sine squared of x. So then obviously that's gone. One of those is gone. I'm left with 1 over sine of x. Now, you can now do that derivative by just going, that's sine of x to negative 1. I can use my chain rule, drop the negative 1 down, take 1 away, so I get negative 2 times the inside derivative. Derivative of sine is cosine. I'm going to drop the sign down because it's a negative exponent, so I get negative cos of x over sine squared of x. That is a lot easier to do. Okay? Moral of the story, people, simplify if you can. And the trig stuff, you usually can. Not always, but usually. Okay, I need a break. I'm going to take a drink of water. Be right back.